Hello, so I prepared a little flowchart to just go over in high level very quickly about some process that, over Airbyte, and here we go. So with Airbyte, we've seen that we can use this to have some data when we as a user have data or an API database, whatever. And Airbyte provides a large selection of connectors, right? So I can choose depending on the source, on what's available. This source connector here is going to replicate this data, extract this data from there, and then produce a stream of JSON records of that database. This is then read by some destination connectors. So we have also a large selection, a growing selection of destination that will be implementing this. And now I want to talk, actually dive deeper into these third blocks. That is like a initial transformer step that will do some in very basic transformation, because up to here we are manipulating data that is in JSON format, and we actually want at the end, for the end user, some tables with proper column names and types that we can query and work with. So this would be the role of this block here, and it could also handle the incremental questions and aggregation, historic runs, etc., etc. So it could be a little bit more complex. So let's see. So with Airbyte, as I've said, you can choose a source connector, for example, Salesforce. You can choose a destination, so maybe multiple destinations. So you can pull data from Salesforce and then output it in different location, like Snowflake, BigQuery, Postgre, etc., etc. And here we started implementing the DBT based transformer, DBT open source tool for transforming data with SQL, but we could potentially have another implementation that does it differently, more efficiently, or maybe because DBT project doesn't handle the kind of destination that we want to use. But let's say let's go with we'll dive deeper in the implementation of how the DBT transformer works and what does it do. So we picked a compatible destination with DBT. DBT runs, and what does it do? So let's unzoom here a little bit, and we will see this graphic here. So it's pretty much the same, but with more details on the transformer steps. So we still have here the source connector, the destination connectors, these actually producing JSON blobs, and then we can start asking a question here. Did the user or the implementation of the source define some comparable key? Is something like updated add column that will tell us these are new columns or old columns. Actually, it doesn't really matter much on the transformation. Like pretty much whatever is happening can be done the same with or without it. It might be more efficient with a comparable key. And so let's go over this. So let's say we have one. So the first thing we could do is extract this comparable key and have this micro batch of new data, JSON data coming here. So it's a JSON blob with a catalog. So it's like the JSON schema, a description of all the fields that they have and the types, and this extracted comparable key as well. Then we can do two things. We can aggregate this. This will always have this schema, a few columns that are always the same, and we can aggregate them, just append only, and then add them to this column that will archive all the runs that has been extracted from that source into a proper column here. And this will be useful if we ever want to run some full refresh of the data. But usually we want to run in incremental, so we can just process the new micro batch that just came here and not the old batch of data that we already pulled in the past from the API or the database. So in incremental mode here, what we have a first transformation. This is some Python code that generated some DBT models that knows how to convert the catalog, the JSON schema, into proper SQL queries, and then write a normalized table. And here we still have a micro batch, but in a flattened format, basically. But then we can ask some question now. Is this schema of this newly batch normalized table, is it the same as the one that we have already in the warehouse? Well, if it's the first run, we don't have this part, so the question is like, yeah, fine, it's the same. We can consider we create a new one, empty one, it's the same schema, and we can proceed forward. But if this is the second run, then we can compare the catalog with the catalog of the previous run. If it's the same, then the answer here go here. It's easy. We take this new batch of data, normalized data, we take the old one, we do a union of those two, and that's it. We merge them, and then we can provide this to the end user here with the old data, with the fresh data and the old data. And then here we ask another question: do we have a primary key defined somehow? And if it's yes, then we can actually update the entity that is described by this primary key with the latest change, and we have a snapshot, a latest snapshot, replicate like a mirror of what's in the source. If we don't have a primary key, then we're not able to do this, and we just can expose whatever we have table we have right here, historical view of that, of all the change that we recorded in the warehouse through time. And this table, this is the one with this dotted line here that comes here, back here, when we ask the question, do we have a same schema or not? Now let's say we don't have the same schema because we added a column, we deleted a column, we changed the type of a column or something, so we don't have the previous run has something different, a new old catalog here and a new catalog in this fresh batch of data. What happens is, okay, fine, the schema is different, we have to do some work here, and we come into this blue box of where we have to do some conversions. We have to adapt the old schema, the new schema, do some migration work or something, and make them compatible with each other so we can merge the two tables together. And once we figure out how to merge this, we can go back to here and expose it to the end user as well. And this work can be done on this macro batch or on the archived JSON blobs as well, if we need to go back in time and say, okay, fine, what Airbyte generated as a conversion is not satisfactory, and we can expose this blue area here to the user, and the user could come back and customize it, recode how we do the conversions, change the type, for example, or let's take two fields, other fields, concatenate them or split them or whatever, a different logic. He can comes back, rewrite the conversion code and rerun it on the archived data so that we reprocess the history and everything's better. So the transformation is redoable, and then we can expose that to the end user, and all of this can be handled in DBT. And then this process is the same if we had a comparable key or not. We could, if we didn't have one, then we go on the bottom here, but it's pretty much the same. The difference is that here we wouldn't be able to record less data because of this updated column, and we manipulate a lot more data, so it will be a bit less efficient, more costly in terms of processing, but it's still doable here. That's it.